All right, we're going to solve systems of equations using elimination. So recently we've graphed to find a solution, and now we learned to substitute or use substitution. This is just another way to solve that same sort of system of equations, but it's called elimination. So our goal is going to be to add our two equations together, and one of our variables will cancel off. Okay. Once you isolate that variable, you're going to solve that equation that's left over, and then you're going to use that solution from step 2 and plug it into the original equation to get your second variable. Now, it's going to make a lot more sense when we look at our example. So if you look in your foldable, we're going to do these 3 examples together. Sorry, I'm getting my foldable. All right, so here, if we look closely, so example 5, we are going to add, like I said, we're always going to add our 2 equations. So we're lucky because our 2 equations are already set up so that this will work very smoothly. Our goal is to cancel off a variable. Well, that means that they have to have opposite signs and they have to have the same coefficient. And we get really lucky if you look at your y's, they're both 5s and they have opposite signs. So when we add this, we'd have a 5y plus a negative 5y. Those will eliminate to 0, which is the point of this method. So we're going to go ahead and add these 2 equations together. 2x plus 6x is where I get the 8x, and then 17 minus 9, or plus negative 9, gives us 8. So here now we have an equation that we can solve. So we're going to divide by 8 to get x equals 1. And now I take x equals 1 and I plug it into either one of these top 2 equations for x. So I went ahead and plugged it into the top equation. So I have 2 times our x value, which we just stated was 1, plus 5y equals 17. And now I just solve for y. So that's 2. I went ahead and subtracted that 2 to the other side, which gave me 5y equals 15. And then divide by 5 to get y equals 3. We still must write our answer as an ordered pair. So our solution is 1, 3. Again, to check your work, you can plug 1 in for x and 3 in for y into both of your equations, and it should work. So, like I said, we got really lucky here. Our y's canceled automatically. Let's look at an example where that's not going to be the case. So here in example 6, we see that my x's are negative 2 and 7, and my y's are 15 and negative 5. Obviously not going to cancel. However, we are allowed to multiply either equation or both equations. So if one of your coefficients is a multiple of the other, that comes in handy. So if you look right here, we can multiply 5 by 3 to get it to be a 15. Our signs are already opposite, so we can just go ahead and multiply this entire equation by 3. We have to multiply the entire equation, otherwise we change the original value. So what I did was just copy down my first equation, negative 2x plus 15y equals negative 32. Then I multiplied the second equation by 3 and wrote that here. So I get 21x minus 15y equals 51. And now if I add my 2 equations, my x's will become a 19x, my y's cancel off, and negative 32 plus 51 gives me 19. Again, I can solve for my variable, so we get x equals 1. And now I plug that into one of my original equations. So again, I plugged it into the top equation. However, you are more than welcome to plug it into the second equation and you'll get the same answer. So negative 2 times 1 plus 15y equals negative 32. That is a negative 2, so I add it to the other side and get 15y equals negative 30. That means y equals negative 2. So your solution is 1, negative 2. Okay, so example 5, super easy. Example 6, medium. We just had to multiply one equation. Example 7 is going to be a little more challenging, but it's definitely manageable. So here we look at our 2 equations. 3 and 4, those don't cancel. 2 and 3, those don't cancel. But I can multiply either or both equations. So we need to multiply both equations in this case because none of our coefficients are multiples of one another. So the easiest way to do this is to switch your 2 coefficients. Okay, so multiply the top equation by 3 and the bottom equation by 2. I guess my apologies. I'm canceling the x or the y, so that's why I chose 3 and 2. However, you could cancel your x's and then you would multiply the top equation by 4 and the bottom equation by 3. Okay, I did have to multiply by -3 because our signs are both positive, so one of them has to become negative. So let's multiply through. The top equation looks like this once you multiply by -3. The second equation looks like this once you multiply by +2. If we add our two equations, we get -x equals -7. Divide by -1, you get x equals 7. Take x equals 7, plug it into either one of your two equations. Again, I chose the top. So you get 21 plus 2y equals 1. Subtract your 21, you get 2y equals -20, which means y equals -10. So your final solution for that problem would be 7, -10.